After the closure property of whole numbers, now it's turn for commutative property of whole numbers. And let's start with addition first. So for addition first, commutative property. In case of addition, what commutative property means is, suppose you have two numbers A and B. Okay, so if A plus B, so can you write it as B plus A? Would these two be equal? That is what actually the commutative property is. And you can check it by example, like if you take A as 2 and you take B as 3, and if you add it, you'd get 8. And if you take B first, that is 3, and that is plus 2, and even in this case you'll get 8. So this A plus B is equal to B plus A. That is, the operator is same, that is, the operator is addition sign here is same, but you have reversed the order. You have reversed the order of the numbers, and therefore at the place of A you got B, and at the place of A you got B, and at the place of B you got A. Therefore, addition of whole numbers follow commutative property. They follow commutative property, that is, they follow commutativity. That is, if you change the order, then they will give the same answer. So this was for addition. Now let's do for multiplication. Let's do for multiplication. Now, what does that mean is, A multiplied by B, is it equal to B multiplied by A? If yes, then it will also follow the commutative property of whole numbers. The multiplication of whole numbers will follow the commutative property. And therefore, to check this, you can take the same example of 2 and 3. So 2 multiplied by 3 would give you 6. And 3 multiplied by 2 would give you 6. In both the cases, you got the same answer. Okay, what you did, at the place of B, A, you put B, and at the place of B, you put A, and therefore you got these two different expressions, but you got a same answer. Therefore, even multiplication, just like addition, follows commutativity. It follows commutativity, that it follows the commutative property. Now let's do for subtraction. Okay, so before going to subtraction and division, now you would be thinking that, hey, what's the use of this? So let me take you an example for multiplication case. Suppose this is a room. Okay, this is a room, and in this room, you have to make arrangement for 32 members, for 32 persons, for 32 people. Okay, for 32 people, and you say that, okay, what we can do is let's make 4 rows. Let's make 4 rows. 1 row, 2 row, 3 row, and a 4 row. And in each row, let's put 8 chairs. So chair number 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So in each row you put 8 chairs. Therefore, there were 4 rows, and in each row there are 8 chairs. Therefore, in 4 rows you will have 4 multiplied by 8 is equal to 32 chairs. Okay, so total would be 32 chairs for 32 people, but in 1 row there were 8 chairs. What if the organizer tells you that, hey, we can only put 4 chairs in a row, because that is what the capacity is. That is what the capacity of the hall is. We cannot put more than 4 chairs. Then what would you do? You have to make arrangement for 32 people, and for arrangement of 32 people, there is a condition that in one row you can only put 4 chairs, not more than that, because that is the capacity of the hall. Okay, so what would you do? So you would say that, okay, what we can do is, we don't have any restriction, we don't have any constant on the number of rows, we have only constant on the number of chairs within a row, and that is 4. So what we can do is that if one row contains 4 chairs, what we can do is, let's make 8 rows, and in each row there would be 4 chairs, and therefore we'll get total 32 chairs, and therefore these 32 people can sit on that. And if you would notice that this is what same thing, that 4 multiplied by 8 is equal to 8 multiplied by 4. This is a real life example, and you can relate this, that how is the multiplication that follows the commutative property is useful in our day-to-day life. And this was example. In both the cases, you see that you are getting 32 as the answer, and you can see that multiplication is following the commutative property. So this is one of the real life example. Now let's move towards the subtraction. For subtraction, so if subtraction follows the commutative property, what does that mean? What does that mean is, if A minus B would be equal to B minus A, right? If you change their order, if you change the position of A and B, so in order to follow the commutative property, the answer should come equal. And you can take the example. So if this is A was 2 in this case and 3 here, so 2 minus 3, and in this case it would be 3 minus 2. Are these two same? No, they are not same. They are not same. This is minus 1, this would come minus 1, and this would be 1. So of course minus 1 is not equal to 1, right? This is not a whole number. And you are not getting, you're not getting the same number, desired result. Therefore subtraction does not follow. It does not follow the commutative property of whole numbers, and therefore it does not follow the commutativity. And last one is for division. Last one is for division, and for division to follow the commutativity, it means that it will have to be that A divided by B will have to be equal to B divided by A. And you can check it with any example, like suppose you are taking it say 4 divided by 2. So is 4 divided by 2 same as 2 divided by 4? No, of course not. Here you will get the answer will be 2, and here the answer would be 2 by 4, or you can say that 1 by 2. Okay, so the answer is coming 1 by 2 in this case, and in this case you have 2. Of course these two are not same, and therefore for division of whole numbers you will not always get this, you will not get the same result if you change their order or change their position. Therefore, just like subtraction, division also does not follow the commutativity. Only addition and only multiplication of whole numbers will follow this commutative property. And here we can relate a real life example. Just we saw here that how is this commutative property of whole numbers is important for us. And in next video we'll learn about the associative property of whole numbers.